Hi, my name is Kane, and today I want to tell you about our idea for our project. What we decided to do for our project is to use a radar that can see people through walls, and the radar that it uses specifically is an SFCW radar. And although we acknowledge that bulkier versions have already been created, what we want to do is expand that idea to create a new radar system that can do the same thing, but instead of being a bulky system that you have to attach physically to a wall itself, we would instead attach it to drones and then strategically place them on an XYZ axis in order to be more precise when spotting human targets hidden within buildings. And that so then our final goal is to basically use this system for military application, as when let's say Navy SEALs have to go into storm a building and take out a certain person or retrieve a hostage. It would then have the drone set up in these strategic XYZ planes to basically show exact pinpoint locations of where each target is. And so as the SEALs or regular Army soldiers are clearing out rooms, well, they'll have a specialized helmet that basically can help them see through walls, so they'll actually know where the enemies are, and so that'll basically decrease the harm that our soldiers will run into, as they'll be able to know where exactly every danger is coming from, no matter where they are. And you might ask what kind of headwear we're expecting our soldiers to wear. So basically, what we saw in doing some research is that their F-35 pilots have a specialized helmet that's super high tech, and it allows the a pilot themselves to basically look all 360-degree every angle up and down, look through their they can look basically look at their feet through the plane to see, thanks to the plane's like systems, whatever radar systems and stuff, project that information into the helmet itself. It'll be able, if they look down, they will be able to see, enemy aircraft below them, above them, to their left and to their right. And so our thing is we want to basically make a special type of algorithm that we can implement into basically a similar type of helmet wear for ground soldiers. And so they basically do the same thing. Storming into a building, they'll be able to look to their left, to their right, and even there's a wall there, because of the drones are placed at those XYZ coordinates, they'll be able to pinpoint. All right, there's about maybe 3 or 4 people past this wall. We know exactly where they're at, and so we can just go in, and with that information, it'll help them clear out that room with minimum to no casualties.
What we propose is a series of drones, a blanket of sorts. These drones will be equipped with SFCW radar. They will cover a structure or a wreck or any object on all 3 dimensions. The 3 dimensions of coverage will allow us to find the exact coordinates of targets located inside with extreme accuracy. This will then be sent wirelessly to a computer algorithm that will interpret the data and feed that to any compatible device. This can include tablets, AR helmets and goggles, and much more. While our main purpose is for military use, this can be applied to many other applications, which we will cover on later. The drones are not the only vehicle for this radar. Larger versions can be mounted on vehicles. In times where a simple view of the field is all you need, large, fast-moving vehicles are the best option. This can allow for a wide range of vision and much more distance to be covered with slight reductions in accuracy. As I touched on earlier, this technology will work at its maximum potential when paired with a few other technologies. The first is a specialized computer algorithm. We want the users of this technology to not have to worry about interpreting the data and taking away valuable time. Another technology that this will be paired with is AR goggles or an AR headset. This will allow for a real-time display to a soldier's HUD, therefore ensuring accurate and up-to-date information.
Why is our idea worth anyone's time? Well, in military operations, search and rescue efforts after a natural disaster, hostage situations, and other similar cases where the location of people within a building is critical information, our product will have a sizable effect on the chances of a mission being successful, as well as to help decrease lives lost. When planning an operation, information is vital for success, and our product's sole purpose is to gather precise information concerning the location of people within a building that could not be acquired by other means. Access to this information will allow soldiers, police, firefighters, etc., to make critical decisions that could decide the fate of others.
Stepped frequency continuous wave radar, or SFCW radar, is a type of radar that transmits and receives a continuous signal. It is integrated with Doppler radar, which helps it phase out stationary objects. When the radar is being operated, a constant signal is being sent through the wall and into the room. The waves travel until they reach a moving target and then are transmitted back to the receiving antenna. Large stationary objects are filtered out to help keep clutter down and allow for the data to be interpreted with more accuracy. Depending on the frequency of the radar, different types of detections can be made, ranging from someone running to a stationary person breathing. You might be wondering how the radar is able to distinguish, say, a wall and a person behind that wall. Wall reflections are usually the strongest reflections when looking at data from an SFCW radar. One way this is mitigated is by comparing the echoes of the received radar. A wall is stationary, and therefore adjacent echoes will all be the same. This can be combined with multiple antennas and receivers to detect which echoes are the same and which are different. The similar echoes, which represent the wall, can then be filtered out, leaving only the target. As you can see, the first radargram shows a lot of background interference, as the subtraction has not taken place yet. Once the subtraction and filter has been applied, we get this image, which is much easier to interpret the data. All of these factors together allow us to create a unique application for radar. SFCW radar is also simpler and cheaper to build as the transmission is continuous. There is no maximum or minimum range, but it is dependent on broadcast power.
Most wall-penetrating radars usually operate at frequencies anywhere between 10 MHz and 2.6 GHz, depending on the desired range of the device. Our radar will operate at frequencies within the range of 1 to 2 GHz with a bandwidth of about 1 GHz. The device will also require antennas with very high directivity in order to increase the accuracy of data. These specifications will allow for detection of mobile and stationary targets through solid surfaces within a range of 30 meters. These figures depict a wall-penetrating radar detecting a person walking perpendicular to a concrete wall. Our device would receive this data from multiple directions, allowing the system to pinpoint the location of this person within the building.
Our three major challenges are durability, power source, and size and weight. For durability, the main system body of the radar will be placed inside a Kevlar woven backpack with carbon fiber plates woven into vital areas to ensure the carrying module is strong yet lightweight. For our second challenge, we faced our need for a reliable, long-lasting power source. To solve this, we have chosen a lithium-ion battery that has both a long lifespan if taken care of properly, and can meet the required power needs of our radar. The third challenge we faced is size and weight. This was addressed with our solutions to the first two challenges, but these solutions alone will not cover every case and scenario. For instance, if a stronger radar is needed for the ability to see through a thicker or more dense wall, then the same upscaled version of our system can be mounted onto a vehicle such as the High Mobility Multi-Purpose Wheeled Vehicle, or Humvee.
We've already covered the topic of what we want our product to basically be used for is, military use, whether it be the Navy SEALs, the Air Force, ground troops in Afghanistan, stuff like that. We'd also love to, expand this concept to be accepted by other types of organizations that could use this technology and find it very useful, such as firefighters. When a building's on fire, they have basically a short amount of window of time to go into the building and try to extract and find as many people as they can. So basically use that for use for the firefighters so they can immediately go in where they need to be and realize, okay, there's people here, here, and here, and then extract them. Same thing with police officers. Hostage situations, police officers like, all right, we have a person who is in a dire situation, and so we need to get as much information as possible before we make our next move in order to save that hostage and apprehend the criminal. And so same thing, use that same technology. They'll have most of the information that they need. And then also expand that even more, we can do disaster help, such things as Haiti, big earthquakes that happen, in Japan, stuff like that. It can be used to help find people in the rubble. This product that we have, this idea, can be used for so many good things and help so many good people. And so that's what we like to do, is not only use it for military use, but also everyday use.